Welcome back, everybody. We are up to lesson 3 of unit 3. And in this lesson, we're going to talk a little bit more about square roots and cube roots. We had talked about square roots and cube roots in the previous lesson. But what we want to do is we want to relate square roots and cube roots to exponents. And it turns out that square rooting, as it says here on the screen, square rooting is the same thing as taking that number and raising it to the power of 1/2. So taking the square root of a number is the same as taking that number to the power of 1/2. So I gave an example here that we all know already. We know that the square root of 25 is positive or negative 5. We could also rewrite the square root of 25 as 25 to the power of 1/2. If I were to go in a calculator and type in 25 to the power of 1/2, I would get an answer of 5. So long story short, square roots is equivalent to an exponent of 1/2. Cube roots is the same thing, except cube roots are equivalent to an exponent of 1/3. So you could see here, taking the cube root of a number is the same as taking that number and raising it to the power of 1/3. So taking the cube root of a number is the same thing as taking that same number and raising it to the power of 1/3. So here's again an example that everybody knows. We know that the cube root of 8 is equal to 2 because 2 cubed, 2 times 2 times 2 is equal to 8. We could also rewrite the cube root of 8 as 8 to the power of 1/3. Again, if I were to go in a calculator and type in 8 to the power of 1/3, I would also get an answer of 2. So what we're doing is we're taking square roots and cube roots and we're converting them from roots form to exponential form and vice versa. So let's take a look at the examples here. So number 1, solve the equation x squared equals 11 and write the solution in 2 different ways, using exponents and using roots. So with that in mind, if we were to solve the equation x squared equals 11, we would solve that by taking the square root of both sides. Why would we take the square root of both sides? Because square rooting and squaring are opposites of each other. Square rooting and squaring are opposites of each other. And essentially what happens here is that the square root cancels out the squared. So square root cancels out squared, and I'm left with x, which is exactly what I want. On the other side, I have to take the square root of 11. Now remember, when I take the square root of a number, that could be either positive or negative. So I know I have to do plus and minus. Now in this case, square root of 11, is that a perfect square? And the answer is no. I know that 9 is a perfect square because the square root of 9 is 3. And I know that the square root of 16 is a perfect square because the square root of 16 is 4, but the square root of 11 is not. So very often what I will do is when I write the solution to an equation like this and I end up having to take the square root of a number that is a non-perfect square, I will leave it in square root form. So I will say that x equals positive and negative square root of 11. So x equals positive and negative square root 11. That is actually the answer to part B. This is the solution using roots. So this is actually the answer to part B. To go backwards and do part A, all I'm going to do is I am going to convert the square root of 11 into exponential forms. We know that square rooting is the same as taking that number and raising it to the power of 1/2. So the way I'm going to rewrite it in exponential form is write it like x equals still plus and minus, but instead of writing square root of 11, I'm going to write 11 to the power of 1/2. So x equals positive and negative square root of 11 is equivalent to x equals positive and negative 11 to the power of 1/2. Positive and negative 11 to the power of 1/2. And actually, if we want to be completely accurate, the parentheses should really be here. Positive and negative 11 to the power of 1/2. Positive and negative 11 to the power of 1/2. So this is the answer using exponents. So that's the answer to part A. Number 2, solve the equation x cubed equals 11 and write the solution in two different ways, using exponents and using roots. So if I have the equation x cubed equals 11, well, when it was x squared, I solved by square rooting both sides because squaring and square rooting are opposites of each other. Well, in this particular case, I'm going to do the same thing, except I'm going to cube root both sides. I'm going to cube root both sides because cubing and cube rooting are opposites of each other. Essentially, what happens is cubed root cancels out cubed on the left-hand side, and I'm left with x. And on the right-hand side, now I'm taking the cube root of 11. We talked about in the last lesson, when I'm cube rooting, do I need to do plus and minus? And the answer is no, because cubing a negative actually results in a negative. Unlike with squaring a negative results in a positive. Cubing a negative results in a negative, so I do not need to do plus and minus. The question is the cube root of 11 a perfect cube? And we should know that it is not a perfect cube. If I take the cube root of 11, I'm going to get a decimal. So I'm going to leave the answer, just like with square roots, I'm going to leave the answer as x equals cube root of 11. And just like in number 1, this is actually the answer to part B. This is the answer or solution using roots. So that's the answer to part A. And to write the solution using exponents, so to write the solution for part A, I'm simply going to use the fact from my lesson notes that cube rooting a number is the same as taking that number and raising it to the power of 1/3. So the way I'm going to write it is x equals 11 to the power of 1/3. Again, I do not need to do plus and minus for the reasons that I've stated. X equals 11 to the power of 1/3. So this is the answer to part A, the answer using exponents. So that's it for number 2. Number 3, very simple. Rewrite the cube root of 83 using exponents. So again, we know that cube rooting a number, taking the cube root of a number, is exactly the same as taking that same number, in this case 83, and raising it to the power of 1/3. So rewrite cube root of 83 using exponents. The answer is simply 83 to the power of 1/3. And that is it for this lesson.